Good morning, superhumans. That's all I got for you today. I'm sorry. It's been a bit of a weird one. Before I get into anything else, my weekly Aboriginal awareness shout out is to Corey Tutt and his project called Deadly Science, which is super cool. He's, for a few years now, what he's been doing is using his own money to buy things like science textbooks and then send them to schools in remote communities, particularly in Aboriginal communities. So he's been like a one-man band trying to provide STEM type educational material for these communities. And he's been doing incredible stuff. He supplied like I think it was 110,000 books. Amazing. So he's got a GoFundMe, which is a really good thing to support. So I've just put the Deadly Science link in there. And if you feel like supporting him, please go and do it. That would be really cool. So the last few days have pretty much wiped me out. And I'm running on fumes. I'm being kept up by caffeine and willpower. So one of my plans for today was that I was going to do a lab tour, like a live lab tour. On the stream last week, someone, I think it was Amanda, I can't remember, suggested that I look into DroidCam OBS as a way to use my camera as a portable camera into OBS. And I tried it and it works brilliantly. So what I'm going to do is use my phone and walk around the lab and give you a bit of a tour. But I'm not going to do that today because I need to get the radio mic set up and a couple of other things. And I want to do that properly. So that'll be next week. And then the week after that, I mentioned previously that I would probably have a guest on today. That's not happening. Instead, he is going to be joining us in 2 weeks. And the guest is Tisham Dar, who is the founder of the Watchdog project, which is an open source energy monitoring project. Tish did a talk at the Open Hardware Mini Conference in January, and so what he's done is designed a DIN rail mounted energy monitoring system, which is all open source, and it's super cool. So if you're interested in things like home energy monitoring, Tish is the guy to explain how to go about it. So he's going to be on in 2 Sundays' time, and we're going to go through his Watchdog project and talk about how it works and whatever we feel like talking about, basically. And I think energy monitoring is a really interesting subject. It's something that I'm personally very interested in, and many, many years ago, back at IVT, we did a fairly major energy monitoring project and built a whole lot of devices that were distributed around Australia, and we built a data logging system for it with a reporting interface and everything. It was pretty cool. So, and I've got some energy monitoring stuff here in my house, which I've never actually really talked about, but I personally think it's a very interesting thing. So I'm really looking forward to having Tish on the live stream in 2 weeks. So make sure you come along for that one. Now to Austin says, I've been using DroidCam. Cool. Yeah, I was surprised at how fast it was, because what I tried doing maybe a month ago, a bit longer, I was experimenting. No, this just shows my brain is not there at all today. It was when I did the look at the pick and place machine. That was months ago. What I did with that was I installed some IP camera software on my phone, which provides an RTSP stream, and then I pulled that RTSP stream into OBS, but there was massive lag. It was like 2 seconds or something. It was just ridiculous. It was okay just for showing something like that, but not really very good for most purposes. But I tried DroidCam, and the latency is really, really low. It's good enough that you can use it as a live camera, and it looks fine, so that's great. For those of you who aren't in Melbourne, a couple of days ago we had a really big storm here on Friday, and 3 people died, and there were a few other side effects as well that affected other people. There were big power outages, and there was broadband outage, so no internet in some places for a while, and also there was damage to a water treatment plant that serves the eastern part of Melbourne. So the end result of all of that is that we've been locked down and can't leave the house, can't drink the water because of contamination, had no power and no internet for a little while. So it's kind of back to being a caveman for a while. In fact, my sister-in-law's place, which is not all that far from here, she didn't get her power back until last night. So they basically had 2 days with no power, no internet, couldn't leave the house, and can't drink the water. Bit of a crazy situation. So, what are we doing today, brain? I don't know. Alright, so today what we can do is make it very much a question-driven day. And I see that there are a couple of comments already. And there were some questions that were put into the supporter section, the private section of the Discord. I haven't even read them yet. I just know they are there, which means I'm going to be giving totally unprepared, off-the-cuff responses. And one of the things that Tim just asked, which is in relation to this, is how resilient can home automation setups be to power outages? And yes, I know that was probably a tongue-in-cheek comment because of the whole power outages in Melbourne thing. And Tim said, had to pull the things on my roller doors to get the car out of the garage. Webcams are all disabled. Yeah, okay. So that could be the next 2 hours of discussion. So just to get it totally out of the way up front, one comment that I often get from people when they find out that I play around with home automation systems is I get questions. This is a question I get all the time. But how do you turn the lights on when there's a blackout? That question always amuses me. So I usually answer something like, well, I turn them on the same way that you turn them on when you're in a blackout. So if there's no power, there's no power. In my house, I've got 4 UPSs. 3 of them are in use. One of them is actually not functional. It's got a fault. It explodified a little while ago. I've got it in pieces. It's actually on a bench just out in the garage. It blew 2 of the FETs, like in a proper spectacular way where they explode and bits of the FET end up going all around the inside of the case. The UPS stopped working and I was thinking, what's wrong with this? And I picked it up and it rattled, which is not a good sign. I opened it up and found little bits of the FET bodies strewn around the inside of the case. So it's a particular type of FET. They're high current, like 60 volt, 50 amp FETs, and I've ordered a couple of replacements, but they're not here yet. So that was you didn't need to know any of that. That was all randomly chasing squirrels again. So home automation in a blackout. I have 3 UPSs. One of them is just down below my left foot down here, and it runs this computer that I'm using right now, my secondary computer, which is just above it, and a couple of other things on the bench around me, like I've got external USB disks and all of those sorts of things. And that at least means that my main computer has time to shut down. It's a fairly big UPS, so I could actually keep running on it for quite a while. And I could basically I can shut everything down. There is another UPS which is the same as that one. It's identical, just under, well, you can't really quite see it, but see there's a second microscope down there. It's basically below that microscope, sort of down towards the other end of the bench, and that's running another couple of computers and a couple of other things down there. Then I've got another UPS which is in the switchboard, well, not in the switchboard, but it's in the wiring closet that comes off the garage. And maybe I'll show that to you when I do the office tour next week. So I'm okay for brief interruptions, but and that UPS is running all the Ethernet switches and things like the Raspberry Pi, which is running as the brain of my home automation system, and all of the other bits and pieces that are in that rack. They're all powered off that UPS. So for brief interruptions, the logic or the core of the system can keep going, but of course there isn't enough power from those UPSs to run loads. Things like lights, we just can't turn them on, can't run appliances. One of the things that is kind of nice about it is one of the side effects of having illuminated light switches from the home automation system is that they glow, and at night that actually gives you enough light to walk around. So if you get up during the night and it's black, you don't have to turn a light on to be able to walk out of the bedroom and down the passage to the bathroom or whatever, because the light switches are these little glowing reference points. It gives you just enough that you can navigate around without bumping into things, but they're not bright and glaring. And all of those are powered off the light switch controller, which is running on the UPS as well. So if it's night and we have a blackout, we can still walk around the house without bumping into things. That's kind of cool. Adam S. said, do you have or do you plan to get solar panels? I do not, and I would like to, but that's a major project that I just haven't undertaken. In relation to that, I'd also like to get a whole house battery system so that we could at least ride through short outages, particularly if we reduce loads, like don't run the clothes dryer. Then, if there's a blackout for an hour or two, then we could keep using lights and have the house mostly functional, working through it. Yeah. Now, let's see. Do I want to talk more about that? Okay, I do. There is a specific thing I want to talk about that, but I'll just check for other questions first. Okay, so Adam P. just said, thanks for the MQTT buffer fix. Awesome. So that did work. I'm really glad to hear that. That's cool. That's from last week, and there's a problem with the PubSub client running on Arduino where it's got a buffer limit. I think it's 128 bytes, something like that. I can't remember. So if you try to send large messages like a chunk of JSON, it just silently fails, and that can be really frustrating. So I'm glad that sorted it. Now, the thing I wanted to talk about in terms of home automation systems operating through power outages. Now, the wording of Tim's question, as tongue-in-cheek as it was, is interesting. It says, how resilient can home automation setups be to power outages? There are two things to that. One is what I was just talking about in terms of will they keep working? But there is a more subtle point, which is resilience, and that to me includes recovery. Now, one of the things, so anyone that has built a complex system, and this could be servers or like an office network, will know of the problem of the difference between maintaining the network and changing services when it's in a steady state and doing a cold boot. Now, if you have, say you've got an office network and everything's been shut down, you've had a blackout or whatever, everything's been closed because you've had a public holiday or everyone's working from home for COVID, and then you want to start your office network back up again. If you simply turn everything on at the same time, It's possible that things won't work properly because of race conditions like, okay, in a home automation system, this is the classic one. And a little Arduino board. Wave one around as a prop. A little Arduino, Arduino board. That can start up in, like the startup time on these things is measured in milliseconds. Whoops. So you apply power to it, and within, certainly like within a second, but potentially within milliseconds, it is going to be on your Ethernet and asking for an IP address. How long does your DHCP server take to boot? And how resilient are your end devices to not getting an answer from a DHCP server? So the classic situation, and this is something that I have quite a problem with on my network, and I had a bigger problem with it in the past, and I've tried to fix these sorts of bugs. It's like the classic thing of people saying, oh yeah, I do backups, but if you've never tested your backups, you might not be doing anything. Until you've restored from a backup, you don't really have a backup. You haven't proven that it works. So it's the same thing with starting a complex system from a cold boot. You really need to make sure that everything comes back in a controlled way, and it can deal with things like some devices coming up before other devices. Now, part of the answer to that, and Family Planes has put it right there in the chat, Watchdog timers. Yes, I've talked about this in the past. And do I have one? Yeah, I've got some up in the box up there. Watchdog timers are part of the answer to that. In projects like the rack mount light switch controller, which I did an episode about a couple of years ago, I included a Watchdog timer in the project. So for I'm doing this mental calculation of how deep into this rabbit hole do I go. Alright, so to explain Watchdog timers, for those who don't know what they are. A Watchdog timer is an independent subsystem that looks for yeah, my explanation is kind of garbled here. It is watching to see if the main system is operating correctly, so everything is working as it should. If the main system is not working as it should, the Watchdog timer has the power to take action, which could be something like resetting it or power cycling it or whatever. Now, typically the way a Watchdog timer works, and I went into this in a fair bit of detail in fact, I think I did an entire episode about Watchdog timers. So if you want to know how that works, we could someone somewhere, let's see, I can probably even find this episode. Let's see, but we'll give you the brief explanation anyway. So Watchdog. There it is, Watchdog timers for Arduino home automation. It was episode 15, way back in June 2016. So I will chuck this into the chat. And what it does is, typically a Watchdog timer needs to, it's a timer that if you let it get to the end, it then takes action. So what you have to do is keep resetting the timer so that it never actually gets to its end point. And so what I do in quite a few of my projects is put in a hardware Watchdog timer, which is connected to the reset pin of the microcontroller, and it might have Watchdogs can vary. They can be anything from a few milliseconds to multiple minutes. I typically have my Watchdog timers set to like 30 seconds or a couple of minutes, because if a system stops working and it doesn't work for a couple of minutes, it's not really too much of a problem, typically. You just want things to come back within a few minutes. You don't necessarily need it to be back within milliseconds. So what I do in my projects, like what I did with the light switch controller, is there is an output from the microcontroller which resets the Watchdog timer. And that is only run if the board has successfully got an IP address and connected to an MQTT broker. And if it hasn't done, if it's failed to do that, it just never resets the timer. So the timer starts ticking away, tick, 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 tick. And if it gets to the end of its time and it hasn't been told by the microcontroller, hey, everything is good, it then hits the reset line, the microcontroller reboots, and then it starts its whole process again. So it then tries to connect to Ethernet, tries to get an IP address by DHCP, tries to connect to the MQTT broker, and only if all of those things succeed does it send the signal out to the Watchdog timer and say, hey, it's all good, stop holding a loaded gun pointed at my head, please. And so the Watchdog timer then resets. So it needs to keep being reset within that period, otherwise it goes off. So that was a kind of jumbled explanation. I think I did a better explanation in that video that I linked in the chat. But the end result of all of that is, if you have a system that is reliant on external services and it boots really quickly, what it will do is try to connect to those services, and if it fails, it'll get rebooted, and then it will go through the process and try again, fail, reboot, try again, and it will just keep doing that until those other services become available. So if your DHCP server is part of like a unified security gateway, or whatever device you happen to be running, and it takes a few minutes to boot, the other devices that are dependent on getting an IP address will just keep trying, rebooting, until the DHCP server comes up and they get an address. And then once they've got an address, they will try to connect to the MQTT broker, keep trying, rebooting. When I put it like that, it sounds really bad. You've got all these devices continually rebooting. But what it means is that the system can recover from devices that are starting in an unplanned way, or they're starting in a random order. You'll probably get weird things happening for a couple of minutes, like your light switches will not work, obviously, but then all you have to do is wait, and eventually the devices all will connect to the services they need and everything will begin working. So from a total blackout to starting everything up from scratch, you might have to wait 5 minutes, but then after that all of your systems will be functional again. So that, I think, is a really important issue. So the word that Tim used, which is resilient, I think is a very important thing. Oh, James said, was that Bonnie in the Watchdog timer video? Yes, it was. So Bonnie is our local dog. By local, I mean she's our dog. I don't know what my brain is doing today. Alright, so Adam S. Back to Adam's point about solar panels. I would really like to. I haven't recently, like not within quite a few years, gone through the process of working out the maths on the cost of power and solar panels and payback periods and all of that sort of thing. So I've got no idea where it currently stands in terms of the economic viability of solar panels, and that is probably of secondary interest to me. The primary interest is really resilience to power outages, and that's where things like a Tesla Powerwall or its equivalent sort of thing. There are many others out there. It's just everybody's heard of the Powerwall, so that's what you use to describe it. And people do DIY Powerwalls, and there are plenty of people like Adam Welsh, I think it is, has a YouTube channel where he does DIY Powerwall sort of stuff in his shed in England, I believe. So if I had a source of thousands and thousands of 18650 LiPo cells, then I could probably build my own power wall. But there are only so many projects that I can undertake. Too many, too many. Alright, so oh, Andy pointed out, so there was that thing about the power-up sequence, the Apollo 11 scene, figuring out the correct LEM power-up sequence. Yeah, when your life depends on it and you only get one chance, you've got to get it right. Yeah, oh, and James said, where I used to work, we spent a lot of time making the system resilient. It was a multi-computer, multi-application system which could get all mixed up. Now we had a standalone app just to monitor the other apps that have to be running. It could kill and restart anything that hung. Yeah, cool. So there was a question actually last night on Facebook. There's a Facebook group I'm in for people that are into space technology, like DIY sort of space technology. And there's a guy, I can't remember if he's in Sydney or Canberra, who for many years has been building rovers. Like he builds, it's like with the ultimate goal that potentially it could be a lunar rover, but they're mainly used for educational purposes. And like they're used in they're intended for use in things like the Mars Yard in Sydney. And so he had a question about running two processes in a redundant system so that if one failed, the other one would take over, and how to control power to those two devices. And so anyway, maybe this is getting way too off topic. I should start looking at the chat. In fact, what I should do is look at the questions that are in the Discord and see if there are other things in there. So, live stream questions. What have I missed? All right. Oh, okay. This is worth mentioning. So, Daryl said that he saw this on the Adafruit channel, SPE, single pair Ethernet, sort of a cross between CAN bus and Ethernet. Looks like an interesting technology. Are there cool technologies that you have seen and think are very cool? Well, I think CAN bus is cool. So yes, I saw the SPE Ethernet a little while ago because there was some announcement about new connectors, and it is interesting, but I'm still not sure about the whole thing because I don't know. It seems to be a hybrid technology. Now, for those of you who haven't come across SPE or single pair Ethernet, for regular Ethernet, typically you need two pairs. So you need TX plus, TX minus, and RX plus and RX minus, and then the connections between them are auto-negotiated, generally, at each end of the connection. And for gigabit Ethernet, you need 4 pairs, so 8 wires. There is I don't know how long this has been around. It might have been around for a while. But there's this thing called SPE, single pair Ethernet, which only uses 1 pair of wires. It doesn't have the throughput of normal Ethernet, but I think it has greater noise tolerance. It also doesn't have the distance, so it's like I think it's generally intended for industrial sort of applications, which is often where you would use something like CAN bus. And I think one of the advantages of using something like single pair Ethernet compared to CAN bus is that you don't have to change anything in terms of the software stack. You'd still treat it like an Ethernet connection, but the physical connectors are different. It just uses a single pair instead of the 2 or 4 twisted pairs that are typically used in Ethernet. And so it has some minor advantages, I think. I'm still not even quite clear on why you would use it compared to regular Ethernet, but it seems to be a thing. Maybe someone can explain to me why we should care so much about single pair Ethernet. It's interesting. Yeah, okay. So the rest of Daryl's question was, are there any other cool technologies you have seen and think are very cool? Oh, so many. This is the thing. This is why I keep chasing squirrels. I see things and think, that's cool, I want that. I see that, I want to do that. All these different projects and ideas and things I want to pursue. So let's not get into that too much. Now, that was in the live stream questions channel. What's going on in the general channel? No, nothing in there. Assistive control. Okay. So let me get back to my other back channel that Andy is feeding me. Cool. So Automotive Ethernet. Station 240 said there is also Automotive Ethernet. And JacksTech pointed out it's been around for ages and gets used in automotive and aerospace. Yeah. And I'm still a little bit hazy on why. I think it might be that it is like that crossover between CAN bus and Ethernet. It's like a midway point in terms of performance. It's got the compatibility of Ethernet without the high performance. It's got the connectors, which the connectors for it are designed to be much more sort of ruggedized and industrial. So if you've got devices that are under lots of vibration or in physically bad environments, I think the SPE Ethernet connectors are better than a typical RJ45 thing. And JacksTech said thinner cable looms as well. That's true. Yeah. So if you've got things like a robot or a moving device or some kind of an industrial installation, having wiring looms that might potentially be flexible because they might be moving in a cable tray, not a cable tray, like a drag chain sort of situation could be beneficial as well. Yeah. So, and the other good point, Amori said single pair Ethernet saves a lot on weight that has used in certain applications. Yeah, so I can see where in aerospace that would be useful. And in aerospace, I see CAN bus used a lot. That just seems to be the go-to thing. But CAN bus, this is the big problem I have with CAN bus. It's the lack of I'm pausing here because I'm going to say something that people are going to jump on and hate me for and say I'm totally wrong. All right, what it seems to me is the lack of software stack compatibility and examples. With things like Ethernet, I mean, Ethernet as a technology, if you look at it as just the connection between two devices, you don't have to run TCP/IP over it. There are all sorts of things that you can run over the Ethernet layer, like the very bottom layers of the communication stack, the electrical connection, the how it transfers the frames across the Ethernet. So TCP over IP over Ethernet is the way we typically use it. That's like the software stack. And that is so ubiquitous that when we talk about Ethernet, people don't even really talk about anything else. Like you just assume that it's TCP/IP. But Ethernet itself is the underlying layer that allows those network packets to travel. The network packets could travel on a different transport layer, and the transport layer could carry other things on top of it as well. But the thing is that we are so accustomed to thinking of those things as joined together and everything built on top of that, that there is this consistency in the way devices communicate. They pretty much all assume that that you're going to be using TCP/IP. And so there are so many examples. Now that does mean that there is infrastructure or I hate to use the term, I won't use the term bloat, but that's kind of what I'm getting at. There is, well, overhead is a better way of putting it. There is this assumed overhead in the TCP/IP stack you need it in order for the other layers on top of that to communicate with other devices on your network. And so bringing this back to CAN bus, imagine if instead of just IPv4 and now IPv6 running on the internet, there were like 6 or 8 different different communication systems at that level. Like not the application layer above it. I'm not talking about HTTP versus HTTPS and FTP and mail and all of those, like SMTP and all of those different protocols on top. I mean, below that, imagine if web servers had to be written to deal with not just TCP/IP, but half a dozen other totally different mechanisms that could transport the data from them to something else. There would be a whole lot of fragmentation, and it would just be a total pain. And that's kind of what it looks like when you start looking at CAN bus, because there are all of these different implementations or different methods of passing data across the CAN bus. There's like J1939, there's CAN Open, there's UAV CAN, and like there are just so many of them. Once you start looking into it, just trying to decide which thing you want to use in your project is a real pain. And it seems that just about every week I see someone come out with a new thing, or someone, I just saw this maybe 2 weeks ago. I'm on the OpenPNP mailing list, and there are people posting things there all the time about their DIY pick and place machines and how they're building them. And there is a new CAN protocol that has been defined as part of the new Smoothie board. So Smoothie is a motion controller for doing things like building 3D printers and CNC machines and pick and place machines, that sort of thing. And on the newest Smoothie releases, what they're doing is working on a system where you can extend the Smoothie board by adding peripherals connected by CAN bus. And that means you could do things like add new actuators or sensors to your whatever device you're building, or different motor controllers. Like you could have motors with built-in CAN bus and then just connect them to the Smoothie board that sends commands to move things. But as far as I can tell, what they've done is looked around at all of the different protocols that people are already using with CAN bus and gone, we like a bit of that one, we like a bit of that one, so hey, here's a new CAN bus protocol. And that kind of sums up where I see things are at the moment. It's driving me nuts. CAN bus is one of those things that I've used it in a couple of projects. Chris and I have used it for different things in relation to connecting his wheelchair to other stuff. And in the end, what I've done with those, or what I've done so far, is taken a really crude or naive approach, and I've just treated the CAN bus like a glorified serial link. And what we've been doing is just creating a CAN packet with, it's got the ID and then the payload, and then we're just deciding this particular payload represents this, and that might be the, in fact what we've done is defined this particular packet ID represents the x-axis on the joystick. So then we just send a value, and the value might be between like -64 and +64 or whatever, to fit within a, or is it -127 to 127, something like that. Anyway, I can't remember what the scale is, but it's just a number that you, at the other end, you have to know in your device. If I receive a CAN message and it has this particular ID, then that represents the x-axis of the joystick, and then you can do something with that. But you need those conventions, and you need, and this is really where doing it properly with CAN bus, you have things like dictionaries that represent the particular messages and capabilities of different devices. You need to be able to deal with devices joining the bus and leaving the bus, and there's lots and lots of complication there. And when you start looking at how complicated it is to implement things on CAN bus, every time you do it, it feels like you're reinventing things from scratch. Either reinventing, just inventing it from scratch, or trying to get your head around these existing protocols where there is a lack of examples and the documentation might be very deep and extensive, but it's mostly in the form of specifications. So for me personally, specifications are fantastic as a reference guide, and I rely on them to look up different bits of information, but they are terrible in terms of understanding how something works or how to implement it. So anyway, that's just been my experience with CAN bus. It's one of those things where I love the idea of it, and I've used it successfully myself, but it frustrates me because it feels like it should be easier to use. There should be more examples. Anyway, I haven't been looking at the chat, and I've probably had people yelling at me in the chat for the things I've been saying. Yeah, so Peter Lawler, hey Peter, said my bicycle talks CAN. Yes, just about everything talks CAN now. So, well, Jax Tech said CAN is glorified serial effectively, isn't it? Only to the extent that Ethernet is also glorified serial. I suppose you can think of it as glorified serial. Yes, it's serial with a whole lot of extra stuff built into it. It's the things that CAN bus can do compared to serial, just regular serial I mean, is amazing. The way it handles things like collisions on the bus and prioritization of messages is really, really cool. And the design of it is super clever. I'm really impressed. It's just, I find it very frustrating to use. So, yeah. This is a good point. Daryl just pointed out CAN bus is best point-to-point or multi-drop points along it. Ethernet SPE, so single pair Ethernet, can also have switches. Yes, and that is really quite a major difference. It's a topology difference. Single pair Ethernet is what we would think of as traditional Ethernet. Now I'm going to ignore token ring and all of those sorts of things. I'm talking about the Ethernet that we use today, which is device to device. And if you want to have multiple devices talking to each other, you need something like a switch or a hub back in the old days that will pass the messages between the different devices. So it's on every Ethernet segment, there are only ever two devices. There's one at each end. It's not multi-drop. CAN bus is multi-drop, so you don't typically have a switch, although you can, but you don't typically have a switch in a CAN bus network. It's just a whole lot of devices all on the same piece of wire. All right. Oh, Tim just pointed out, severe weather warning, damaging winds again, Melbourne and surrounds. Oh, great. Thanks, Tim. I was hoping that we were past all of that. Yeah. Oh, Station 240 pointed out, because there is no standard way to transfer files over CAN, there is also no standard way to program devices over CAN. Yes. Yeah. This kind of summarizes what I mean. I think I understand why. And I don't want to get too much into the whole thing about protocol stacks and all of like the communications layers and all of that sort of thing. But what it looks like to me is that when CAN bus was designed, they worried about the low level, and by low level I mean things like the electrical connection and collision detection and how frames of information are passed across the wire, but nothing that happens on top of that. That has just been left to people to implement, and that's why we've ended up with so many different things that sit on top of it, like J1939, etc. Yeah, it's just so annoying, and different things get used in different situations. Like J1939 is typically used in cars, and can open is often used in medical equipment, and like they're all, but there's crossover, and then of course there's UAV can and others. So you can have two devices that are electrically compatible. They both speak on CAN bus. You could plug them together and they're speaking totally different languages. They just can't communicate with each other. Whereas with Ethernet, you plug things together and at least you've got TCP/IP on top of it is typically what people use. So you can at least rely on that fundamental level of communication. You're going to have two devices that can pass packets between each other. All right. So back to some questions. Zach asked, are you still using your automatic window openers, and have you made any changes to them since install? Yes, I am still using them. Since install, so I did a video about this a few years ago, and I have not changed them. I'm kind of carefully phrasing my answer here. The ones that are connected to the house that are shown in that video are still working in the same way as they were in that video. I'm using LinBus. Oh, there's another one to chase. Alright, so CAN bus, controller area network, is typically used in cars. It was originally intended for use in vehicles between electronic control units, and you can have multiple devices and prioritization of messages and all of that sort of thing. LinBus is like CAN bus with a whole lot of the smarts removed from it. LinBus is a simplified communication. Maybe that's all I need to say. It's like CAN bus but simplified. The idea is that it should be possible to implement LinBus. So LinBus really is closer to that comment earlier about it's just glorified serial. LinBus is like a serial that is multi-drop and runs over a long distance and is noise resilient. So you can think of it as being a little bit like, you know, RS-485 or something, one of those classic multi-drop serial connections. And LinBus was developed as an offshoot of the CAN bus project because CAN bus it required a little bit too much in terms of processor time and memory and expense and all of that sort of thing. So typically in a car, what happens is that CAN bus is used for communication between the major controllers in the car, and then a controller might want to control small things just in its local area. The classic example is controls for door locks and window motors. So there will usually be one control system that controls all of the window motors in the car, and it'll be connected to CAN bus, so it can receive commands saying open the window or close the window, but it communicates with the motor using LinBus, which is a simplified, cheaper to implement small connection. Now, the electric window motors that I have in my house to open the windows in the conservatory are LinBus. And so what I did was design a little LinBus module, and then at the moment what I've got is an Arduino, I think it's a Mega, I can't remember, might be an Ether 10, connected to 4 LinBus modules, and each module is communicating with one of the 4 motors. So it's actually remarkably similar to the way a car is set up. It's just that instead of the 4 windows in your car, it's 4 windows in my house. And it's just pure coincidence that it happens to be 4. It could be any number. And so what happens is that when I want to open or close the windows in the conservatory, I can pull it up on my phone or press the button on the wall, and it sends commands over the LIN bus to those motors, and then the windows open or close. So that is all operating exactly as it was in that video from some years ago. And yeah, as Peter said, CAN bus is overkill for your grill vent open or shut actuator. Sorry, mentally pausing because I was just thrown by a comment that I just saw. But it's been blocked by the comment filter, so you don't have to see it. That's good. Back to questions. Well, just to wrap that one off, I did work on, let's see if I can find it. It'd be nice to do a bit of show and tell. Where is it? So Wi-Fi, yes, I think I've got something here I can wave in front of the camera, and I don't have to go too far to get it. Since we're chasing this particular squirrel at the moment, why not keep chasing it? Oh yes, here we go. So this is one of the motors that's used to open and close the window. Let's get that out of the way. Now this particular one, hasn't ever been installed, so there's still the packet. It's got all the brackets and things that are attached to the window frame. It even comes with batteries. Oh, they're branded batteries. Amazing. I didn't even notice that. The batteries that come with the AXA window motor are branded AXA. So I've got 4 of these. In my particular case, they're mounted vertically on the edge of the window frame. And there is a mechanism. That part right there comes out on a chain that opens up and it pushes the window open or closed, and there is a lock mechanism there as well. So it's not just relying on the chain to keep the window closed, it's got an active lock. It slides a little plate down, so there's no way you can get the window open when the motor has closed it, and then the cover goes over there. Now these are designed so that they can be run off infrared. There's an infrared receiver and there's a little transmitter that comes with it, and you can put 4 AA batteries in there. But I hate replacing batteries, and you can power it externally as well. So what I've done is, where is it? Somewhere in there. Oh, there it is. Okay, so these, you can't see it because it's dark. Let me get the angle in there. There are a couple of sockets here. These are sockets for the LIN bus connection. And they're just, it's because of the way LIN bus works, these 2 sockets are just wired directly together. So it doesn't matter which one you plug into. And the idea is that you can plug a cable into one, and then another plug into this one, and then loop it onto the next motor. So you can have a series of motors, and the cabling just loops around between them. And then you can send a command, and the first device in the chain gets an ID, and then the second device in the chain gets an ID. So what you can do is say device 3 open, and then the 3rd window will open. So now I'm actually not using it like that. Earlier I mentioned that I've got 4 LIN bus interface modules that I'm using, and that is because the way these particular devices are set up, the firmware that comes in the AXA devices doesn't support different IDs. So what happens is that if you send an open command, all the windows open, or if you send a close command, all the windows close. I wanted to be able to control them individually. And because of the firmware limitation within this, I couldn't do it unless I had one CAN bus connection to each one. So what I've got is a CAN bus going to the motor, and then it doesn't loop on to the next one. I've actually just got a separate CAN bus to each motor, not CAN bus, LIN bus to each motor. So I can decide which bus to send the signal down and open the window. Now most of the time what it does is it just sends the command down all 4 buses, so all 4 windows open or close, but I can control them individually because I've got them wired separately. Now, oh, and power can come in through here as well. So if you have it connected to LIN bus, it gets power and comms from here, and then you don't need the batteries. But what I've also done, and this didn't work out too well, and I haven't really pursued it, but it's one of those projects where I went part way down the track and then just I kind of forgot about it. I didn't have an immediate need for it, so it just sat there. This weird shaped PCB, which has an ESP8266 on it, and you can see it's got these 2 slots, is designed to fit into the battery compartment. It's got these things in here, these tabs where the batteries clip in, and the idea was that this would just fit over the battery tabs and go inside the battery compartment. Is it there? Yeah, kind of there. But the problem is that it doesn't quite fit the way I expected it to. It might actually work better if it was upside down. So what I need to do is, now that I've made this one, I want to play around with the mechanicals a bit so that I can make it fit directly into this battery compartment. And the idea is that what you can then do is run power to your motor. You don't use the batteries anymore because the battery compartment is filled with this little control board, and then the control board talks LIN bus to this. So this board is actually an ESP8266 with a LIN interface chip on it. Don't know if you can see it. I could probably just pull this up in Eagle, might be easier to see. On this end, that little chip just there, that is a LIN transceiver chip. So the ESP8266 talks serial to the LIN transceiver, and then there is a LIN bus connection here that goes off and talks to this, which is kind of weird because you've got a board that is right here mounted physically inside it, and it's using LIN bus to communicate from here to here. But what it allows you to do is work with the motors totally unmodified. All you have to do is have a cable that plugs in, loops back around to the control board, and as far as this is concerned, it's just receiving commands over LIN bus. But now we have Wi-Fi connectivity, and this is kind of where I think this is actually one of the reasons that I paused on this project, because when you think about it, control of electric windows is, from a security point of view, is fundamentally the same as control of door locks. I mean, if someone can take control of your door locks, they can get into your house. If someone can take control of your electric window mechanisms, they can get into your house. So my general principle has been not to use wireless for anything that is security related. And so, I mean, there are certain situations where where you need to do it, where wireless is a good solution to it. But the thing is that if I have a system like door locks, I don't want to be relying on Wi-Fi to control the door locks. And if they're, I mean, okay, I could, I don't want to chase this particular squirrel, but because I chased it so many times and never caught it, I don't think I need to go into it in a whole lot more detail. If the summary is, if there is something in my home automation system that allows someone physical access to the house, I do not rely on wireless communications for that device. I'm perfectly happy using wireless communications for things that are just like sensors or, you know, those sorts of things. But for doing things like opening windows and unlocking doors, I want to stick to wires for that. Now, what have I missed in the comments? So Frank Marazita asked, do you have any advice for an aspiring software engineer, especially to do with how COVID may be affecting graduates at the moment? That's a great question, and I don't think I've got a very useful answer to it. I'm really terrible with the do you have advice questions, because I don't know, perhaps this is partly my own whole imposter syndrome thing, but when people ask me for advice, I don't feel like I can give advice, because I think because I don't feel like I've been successful myself, so what right do I have to tell anybody else how they should do things? So in terms of how COVID may be affecting graduates, I don't know. And I'm not even sure what the short-term versus long-term effects are going to be. I mean, it's easy to see in the short term how COVID is affecting business and how it's making things like work from home are a thing in a much bigger way than they were in the past. But in terms of how it affects graduates, I don't know. I think the biggest thing is going to be uncertainty, and people or companies being unsure about hiring because their economic situation is uncertain. Now, maybe this is the time to bring up something that I said on Facebook and Twitter a couple of days ago that a couple of people got upset about, and I think maybe because they didn't take it as I was intending it. Okay, so this is getting down to transport and logistics issues. I made a comment, and it was along the lines of, imagine that you were an executive at a logistics company, like a delivery company or something, 12 months ago, and someone came up to you at a party and said, okay, you work in a business that does deliveries. In your wildest fantasy, what is the greatest thing that could possibly be done to make for your business? And the answer would be, how about we lock down the entire population in their homes and tell them that if they leave home they could die, and make them entirely reliant on our services for everything. They have to order everything online, everything needs to be delivered, and logistics services are going to be the only thing that everybody relies on. It's like the dream situation. It is the ultimate situation in terms of taking an industry and saying, we want the entire population to be reliant on you. And that's pretty much what's happened, obviously. And a couple of people, I said something like, for companies that do deliveries and logistics, this should be the time that they should, in theory, be making buckets of money. It's like, it can't get any better than this. This is like Christmas Day every single day for them. And I had a couple of people annoyed at me saying that logistics companies are having a really hard time of it now, and people who do deliveries are not seeing their families, and they're working crazy hours, and they're getting abuse because things aren't being delivered fast enough. And yes, I understand those are scaling issues, and it's very hard to take any business and suddenly scale it to like 10 times whatever it was doing a few months ago. People are going to suffer in that situation. You can have an industry that's been handed like the greatest gift ever, and that gift could kill it because of the load that it imposes on that industry. And I had some people saying, well, are you, that I'm annoyed that places like logistics companies would be making more money now. No, I'm not annoyed. Sorry, this sounds like I am chasing a totally unrelated topic, but this comes back to Frank's question about advice for an aspiring software engineer and how COVID is affecting things. Part of my point of this is that the initial reaction to our current situation with COVID is disaster, doom and gloom, and totally understandably, a lot of the focus is on the things that have been destroyed or taken away, or the things we can't do now, the industries that have suffered as a result. But when there is a major shift in economic structure and in supply and demand and in services and those sorts of things, there are industries that will suffer and fail, but there are also new opportunities, and there are things that will grow and thrive and prosper as a result of this. So right now, I'm sure there are many industries for whom this is the greatest opportunity they will ever see, and they're probably hiring as fast as they can. This is their chance to make money. So in terms of looking forward as a software graduate, I suppose the thing is just to keep your mind open to industries that may be thriving in the future as a result of this, and see if there are opportunities there. Obvious things are medical related, things like testing systems, and I think for quite some time now, we're not going to have a situation where we flick a switch and we go back to life as it was before. Things like work from home are going to be much more prevalent in the future than they were 12 months ago, and all of these. So there are, okay, another example is companies that provide video conferencing services. Now, I bet that 12 months ago, most people had never heard of Zoom. Now, everybody's using Zoom. You know, there are opportunities like that. There are businesses that are for whom this is the greatest opportunity ever, and they are just scaling like crazy. So, as a graduate, I suppose think of it in those terms. Look for where the new opportunities are coming. What else? There are a couple of questions in there related to Home Assistant and cards, but there have already been some answers, so I'm not going to get into that. And also, I am definitely not an expert on that. So James asked, in relation to assistive tech, do you look at power consumption and sleep modes when doing assistive tech, specifically battery-powered devices? Ooh. I'm not even sure how to answer this, because the assistive tech projects that I have worked on so far have not been battery powered, and most of them have been wheelchair related. Now, when Chris and I did our presentation at LCA earlier this year, one of the questions that we got was, and this is because we had a wheelchair set up with a Raspberry Pi on it, and we were actually running CAN bus from the Raspberry Pi to the wheelchair motor controller that we designed. And in the talk, I drove the wheelchair around in the lecture theatre using a Bluetooth game controller that was paired to the Raspberry Pi. So I was running a Raspberry Pi, which pull a fair bit of power. Like, they can pull a couple of amps in theory, depending on what they're doing. And someone asked the question, is it a problem running a Raspberry Pi on the wheelchair because of how much power it pulls? The short answer is no, because wheelchairs have huge battery packs in them. The drive motors in a wheelchair, they could be pulling 60, 80, 100 amps per motor when that wheelchair is going quickly. So, and a wheelchair will drive around all day. It's got so much battery capacity that when we're building things to go on wheelchairs, it just never even crosses our mind to care how much power it's using, because there is no way we can use as much power as the drive motors are using, not even close to it. So there are a couple of things that we've worked on, like we've worked on the nurse call system, and we worked on a nurse call system a little while ago for a friend of Chris's. And so what we did with that one was put a couple of plug pack UPSs in place so that it was powered from the mains, but if mains failed, the plug pack would keep giving power. Now these things are actually really cool. It's one of those devices that I had never come across, but when we were doing this project, obviously, the big question is how, for a nurse call system, how do you make it resilient to power failures? It absolutely has to work in a blackout. There's just no question of that, because someone's life is depending on it. And you can build multiple levels of fail-safe into it. But one of the things that I started looking for was, okay, how do we set up a backup power supply for it? And I came across these devices that look like a plug pack. I was just going to wave something around as a prop, but I don't think I need it. So, you know, what many people call a wall wart power supply. Black plastic thing with a power plug on it and a cable coming out and a plug on the end. So you plug it into your power point and you get volts coming out, like 12 volts or 9 volts or whatever. But the clever thing about these particular ones is that the black plastic enclosure that plugs into the wall is slightly bigger than usual, and it's got batteries inside it, and it's essentially a little self-contained UPS. So you plug it into a power point and turn it on, and you get 12 volts coming out. But if you turn off the power point, you still get 12 volts coming out, for a while at least. I mean, it's certainly not the capacity of something like a proper UPS, which has got big batteries in it. But it means that if you've got a device that you need to keep running for an hour or two, and you're not pulling a lot of power, you might be pulling 50 milliamps or something, it'll certainly do that. And so we ended up using those as like an extra level of protection in that project. We use these little power packs with built-in battery backup. So there are certainly other projects where power consumption has been a big problem. But in relation to James's question, for the assistive tech devices that I've been working on so far, generally that hasn't been an issue. So, what other questions? So Jordan said, do you use any multi-tap functionality in your house? Their multi-tap functionality. So, Jordan, by multi-tap, do you mean an interface like where you tap on a bench in a certain pattern and then something activates? Where is it? In fact, I've got one of those devices. I think it's up on a shelf. Just up there. Oh, Andrew said I've got one of those wall wart UPSs for my cat flap. Yeah, it's one of those things that is surprisingly cool and obvious in retrospect. It's like plug pack with a built-in UPS. So James said the clapper, clap on, clap off. Yeah, I'm not quite sure what is what the multi-tap thing is. There was a project. I can't even remember what it was called. Sorry, I'm wandering around at the moment because I just wanted to see if I could easily spot it. I had one. I backed it on Kickstarter, I think it was, and I don't know what happened to it. Might have been. Don't know. Somewhere around, I've got a little device that is kind of like a puck, like a hockey puck sort of thing. And you sit it on your bench, and you can teach it patterns. So what you can do is, Jordan, you might have been talking about multi-drop since I was talking about CAN bus scenarios 485. Okay, that, yeah, oh no, light switch or similar, 1 tap for normal function, extra taps for other functions. Yeah, so Nema pointed out, as I've said, I'm not a fan of that from a user experience perspective. Yeah. Now that tapper interface, I will probably get back to that at some other point, but since that was not what you're talking about. All right, so the short answer is no, I haven't done that. And as Nema pointed out, I'm not a huge fan of that because I see it as being, all right, there is something that a friend said to me many years ago because he had just switched over from using Windows to Mac OS. And I don't want to open up a whole argument about this right now, but he pointed something out to me that I'd never noticed because I'd already been using Mac. He switched to Mac, which meant that he was coming into it from the perspective of someone that didn't have experience with it, and he was learning how things worked. And there was one thing in particular that he pointed out, which is how you go about renaming a file in the Finder. So in Finder, if you click the name of a folder or a file or something, and you click with the cursor over the name, you just click it once, and then you wait a couple of seconds. I'm not sure what the delay is. Then you can go into like an edit mode for the name of the file. And then you click a second time to click into the name, and then you can edit it. I'm describing this really badly, but this is the trap. If you want to open a file in Mac OS, you can double click the name or the icon, but if you double click the name, it opens. If you click it once and then pause and then click again, you will be editing the name. And it is the exact same action. It's 2 clicks. The only difference is how quickly you do it as to whether you open it or rename it. And when he came across this, my friend said, this is stupid. Like, this UI thing is just ridiculous because, well, for a few reasons. Firstly, it's opaque. You might do something where your timing, like perhaps your physical dexterity is not very good, and so your double click is slower than normal. And then you're unexpectedly editing the name of a file instead of opening it. Or maybe you're wanting to rename a few things, and you now have a delay imposed by the operating system where you've clicked on it and then you've got to wait, and then you click on it again before you can rename it. Whereas if you wanted to rename it, you want to be able to just go straight into renaming mode quickly. So it would actually make a lot more sense if you click in the name of an object, it just immediately starts editing the name. If you click on the icon of the object, it opens it. Because those are 2 distinct actions, and it is 2 distinct outcomes. It's not the same action with 2 different outcomes. And so, yeah, the statement he made was something like, anytime that there is a delay induced into interacting with the computer, it's a user experience fail. So in this particular case, what macOS does is it imposes a delay. It forces you to click and wait and then click again before you can rename a file. And so somewhere in the Finder code is a little timer that starts running, and you've got to wait for that timer to expire before you click again. Otherwise, it will open the file. And in fact, there's no visual feedback of what's happening. You can't even tell. So you don't know if you waited long enough. It's just one of those really niggly little things. I'm going into this in a lot of detail. But what I'm trying to do is use it as an illustration of a user interface experience that is unpredictable and frustrating. It's frustrating in multiple ways. It's frustrating because it might just do something you're not expecting. Like if you are a little bit too in a hurry and you want to rename the file, you might open it accidentally, and now you've got to go, oh no, it's opening, you've got to wait for it to open and then close it, and then you can rename it. Or it also means that it's not obvious what it's doing. It's not easily discoverable. And discovery, I think, is an important thing, particularly with things like light switches in a house. I have enough trouble with guests just pressing the button to turn the lights on and off. That is more than the majority of people who visit my house can figure out. If there were multiple modes, like you press the button and hold it, and now it goes into a dimming mode, they probably wouldn't discover it accidentally. And if they did discover it, they would think there is something wrong, or they wouldn't figure out how they had done it. Like they would click the button to turn the light on and not release it quickly because they don't realize they have to, and they keep holding it, and then the light would start to dim and they go, why is the light dimming? I was trying to turn it on or turn it off. Yeah, just leads to confusion. So my personal feeling is that having the same function or multiple functions on a single button is suboptimal. Let's just say that. Time for a drink. At the moment, I can't just grab a glass of water because we've got boiled water in a jug in the fridge, but I can't just fill a glass of water from the tap. All right, what do we have? Questions, please. Oh, James pointed out, yeah, mystery meat navigation. So yes, I've used that term in the past as well. So mystery meat navigation is a term that was coined, I think it was in the mid-90s or late 90s, for early web user interfaces where there were just icons that didn't necessarily mean a whole lot, no text labels, and then you'd have to mouse over it and then the icon would change to something else like a label, and then you could tell what it was. So you would end up just sort of scrubbing your cursor across the navigation bar to make the icons change into their labels so you could read them, and as soon as you move them off, the label disappears and you can't see what it is anymore. There's just some mysterious icon. Anyway, so let's see. Oh, okay. So Jordan said, for me, I use it for things like turning off all downstairs lights when climbing the stairs. Yes. All right. Now, I should point out the difference here. If you are building a system for yourself, you have so much more leeway than if you are building a system that will be used by random other people that you can't even necessarily explain it to. So, for you, living in your house, you've got some stairs and you've got a light switch, and you press the light switch once and the lights turn on or off. Press and long hold and it turns off all the downstairs lights. I think that's a summary of what you're explaining. So if you build that for yourself, that is probably the most convenient thing in the world. It's fantastic. You know exactly how it works. If you went away for a little while, or if you just had someone come and visit your house and they try to use the lights and they press the button and they don't realize they have to press it and release it. So they press it and hold it for a couple of seconds wondering what's going to happen, and then all of a sudden all the lights turn off and they go, what the hell was that? It's just one of those things where if you know it, it's great, it's super convenient. For a random person walking up to it that doesn't know what it does, it's not discoverable. So anyway, Dark said maybe they should have button pushing training at a school level. Yeah. Oh, yes, okay. This is a classic example. So Tim pointed out the reset feature with LifeX is great. People keep switching the lights on, off quickly, and then the lights go to bright white. Yeah. Now that is, if you think about it from the point of view of LifeX, or anyone that makes like a smart device that you've got to be able to put into a factory reset mode, that is a really hard problem to solve. How do you take a device that is like connected up on the ceiling somewhere? The only user interfaces that people have to it are through Wi-Fi or the switch on the wall. They don't have any other way of interacting with it, and you have to allow for the situation of the Wi-Fi SSID changing or the router dying or whatever it happens to be. No more Wi-Fi, no more app control, which means that you have a device that is trying to find Wi-Fi that is just not there, and the only interaction with it that you have is the switch on the wall that controls power to the device. So you're actually cutting power to it entirely. You're not even sending a control signal. You are actually turning off the power to the device when you turn the switch off. How do you put that into a factory reset mode? So coming up with a way of doing that is, it's a real brain bender. So what companies like LifeX and other places do is they rely on things like a certain pattern of switching. So you've got to turn it off and on, a certain number of times within a certain period, and then it goes into factory reset mode. And they're really, whoever has to try to solve that problem, I feel sorry for them, because I don't really know of any better ways to do it. It's not an easy problem to solve, but it does lead to these situations like Tim pointed out. Was it Tim? Yes. So yeah, you can have someone walk up to your light switch, and I've heard of this happening with kids as well, because kids play with lights. They'll walk up and they'll turn the lights on and off because it's really fun. They'll make it, make the lights flash, and then all of a sudden it goes into factory reset mode, and it's no longer associated with your Wi-Fi, and yeah, bad things happen. You got to set it all up again. Yeah. Now, so yeah, I don't actually know. I don't know any better way that companies like LifeX could solve that problem. On the really early globes, I think the very, very early ones, and Andy would know for sure. In fact, something I don't think I've ever really pointed out here. You see Andy here in the chat. He was one of the founders of LifeX, and the very first prototype. So when LifeX did its big Kickstarter campaign, there was the promo video that went along with the campaign, and there were the lights in the lounge room that were changing color, and it was demonstrating what LifeX could be. Now this was before LifeX had actually been done. Those prototypes were partly built by Andy, who is right here in the chat. So there is a celebrity engineer right here. And when the very early LifeX globes went to production, I think they had a reset, like they had a physical reset button in them. You had to unscrew a cover that was on the side of the globe, and there was a reset button in there. But yeah, that was removed. So Yes. Oh, and Andy just pointed out another tricky problem when LifeX light bulbs with a well-known factory reset sequence are used in hotels. You don't want the hotel guests resetting all the lights. Yeah, that's right. Because the thing is that the factory reset process has got to be well known. It has to be documented and it has to be the same for all lights. So if you know how to reset, it's not a secret. If you know how to reset, like factory reset a LifeX light, and you're feeling really malicious and you go to someone's house and they have LifeX lights, you can go around and factory reset all of their lights, just to be really annoying. So, all right. There was a comment by Thomas a couple of minutes ago, which which I haven't responded to yet because it's an important one and I wanted to get to it. Thomas Meyer said, do you have any plans to cover design of MQTT topic structure for maximum usability? Many ways to set up topics and hierarchies, and a discussion around design could be very useful. Yes. Do I need to give more answer than that? Yes, I do. All right. I have touched on this a little bit in the past, and so once again, you can see the very slow motion cogs turning inside my skull. All right, a very brief restatement of the problem. This is the classic thing that people ask when they first start using MQTT, which is, how do I set up my topics? The classic scenario is, okay, you're putting a temperature sensor in your kitchen. Should the topic structure be kitchen/temperature, or should it be temperature/kitchen? The reason people ask that question is that there are different ways you can think about all of the devices on your network. You could think about it from the point of view of geography. You want to see all of the devices that are in the kitchen. That could be temperature sensor, humidity sensor, the state of the lights, whether the exhaust fan is on or off, whether the dishwasher is running, all of these different things. You might care about the geographical location of the kitchen, in which case it makes sense for your topics to be kitchen/lights, kitchen/temperature, kitchen/humidity, or whatever. Or you might care about it from a data point of view across geography. So you might want to think about, what is the temperature across all of the rooms in my house? Because we might have one room that is getting overly hot and other rooms are not heating up as much just because of the way the heating system is working. And in that case, it makes sense to call your devices temperature/kitchen, temperature/lounge, temperature/bedroom 1, and think of it from the point of view of temperature sensors wherever they happen to be. And so this is, those are just 2 dimensions. You can slice it in all sorts of different ways. And like pretty much everybody else, this was a question that was buzzing around in my head in the early days of using MQTT. And this is a question that comes up over and over again, constantly. I see this coming up. In fact, I saw it only a few days ago in the I'm in a couple of Facebook groups for home automation, and it came up with someone saying, I think it was Aussie and Kiwi DIY home automation, that Facebook group, something like that. And someone said, I'm just setting up Home Assistant, how should I name my topics? So this is something that is a really big issue. And one thing that Andy made me realize many, many years ago is it doesn't matter, because you can't solve the problem by structuring your topics in a way that makes sense for all scenarios. So there is no point trying to force your topic structure to make sense for slicing the information by type of sensor across an area, or by all sensors in a geographic area, or by whatever dimension you want to slice it. You can't solve all of those problems by structuring your topics in a certain way. And so there is a better way to do it. And so Andy's solution to this, it's a multi-facet solution, is a combination of service auto discovery and tags. And I may be, hopefully I'm not misrepresenting what Andy's solution is here. This is my understanding of of his ideas. But so there are a couple of different parts to it. Tags allow you to find things based across multiple dimensions. So instead of thinking about your topic structure as being a way of illustrating data about those devices, like where they are located or what type of device it is or anything else, don't bother using the topic structure to illustrate that. Use tags. And what you could do is you've got a device which might have a particular ID, and the ID could be based on the MAC address of the device, for example, so it's unique. And you'll have a device which could be in a topic, it could be just device slash ABC123, just the MAC address. And then there are multiple topics within that potentially as well, like that could be then slash temperature or slash power or whatever. But the structure leading up to that doesn't really matter. It's really only a way of uniquely identifying the device. And then on top of that, what you can do is use a tag-based system that allows you to map devices for different purposes. So you can say, give me a list of all the devices in the kitchen, or give me a list of all of the devices that have the temperature tag, and therefore they can report temperature. And so that gives you a whole lot more flexibility. And it means that instead of trying to keep track of things, like I used to keep track of all of this in a spreadsheet. I've still got it somewhere. I've got a big spreadsheet that lists all the devices in my house. It hasn't been updated in years, but it used to list all the devices in my house, their MAC address, their IP address, and their MQTT topics, so that I could then go and look them up. And so the approach that Andy prefers is more around having a system that maintains that information for you and can answer questions whenever you want it. So this is a project that Andy has been working on for a couple of decades now, and implemented an early version of it in a project many, many years ago, and is in the process of re-implementing it right now. And so what Andy is working on, and he's very kindly allowing me to look over his shoulder as he's working on it, is a service registrar for devices that keeps track of what devices are registered and what services they can provide. And then you can query it and say, give me all of the devices that are temperature sensors, and it will return a list of all the devices that are temperature sensors. Or you could say, give me a list of all the devices in the kitchen, and it will return all the devices in the kitchen. Or you could say, give me devices in the kitchen that are temperature sensors, and it will give you the IDs of those devices. So that's a project that is coming together. So every Monday evening now for the last couple of months, I think it is, I've been getting online with Andy, and we've been coding up the service registrar. And hopefully fairly soon there will be a whole lot more information about that. It's written in Python, which is not something I have much experience with at all. So it's been a really interesting educational experience. We've been using tmux for it, so I've been sitting there in the tmux session watching all the code as Andy has been editing it and adding features, and we've just been chatting about it while he's doing all the typing. And that has been a really fascinating thing to go through, to see how it all comes together. There is a whole lot more that I could talk about that, but what I really need to do is get Andy on this stream sometime, and then he can give you the proper expert answers to questions in relation to it. I'm kind of just giving you my second-hand, non-expert, looking over the shoulder answer to the question. All right, so, and John Clark pointed out, this is the problem with any hierarchical structure, file systems, etc. In the old days of physical files, we had to put multiple copies on multiple files. Okay, for symbolic links. Multiple file systems. Yeah. And Jack's Tech said, I personally use a unique topic for every device. Yeah. Okay. Question is, do we go more into that? I don't know. Maybe. Andy, is there anything else I should be pointing out in relation to that? Or should we just keep people hanging on and show them something a little bit later? So this is something that Andy and I are intending to talk about a lot in the future, because it's such a foundational thing. It's like the plumbing that lets everything else work. And I don't want to go into it too much because, as I said, I'm not the expert in this area. But what I've talked about in terms of tagging of devices and a registrar that provides discovery those are just two parts of the puzzle. Andy's ideas go way, way beyond that, and he's got some really cool stuff in relation to things like pipelining. And this is an area where, all right, I'll try to explain this. I'll explain it badly. The idea behind this is to have flexibility in how devices are linked, and to be able to create pipelines where you have multiple devices or services that interact and pass data between them. One way to think of it, if you've used Node-RED, I suppose, could be a reasonable analogy. With Node-RED, it's very much like a flow chart, or it's information passing along a series of things, and it can branch and join, and it's got logic and those sorts of things. So with Node-RED, you can have information coming in, and then you process it, and then it goes to another node, and then something else happens, and it goes to another node. What Andy is building is essentially like it's a system that works in a similar way with devices and streams of data, so that you can pass things around and use building blocks to build more complex systems. Okay, I'll give a little example. Imagine you have a video doorbell. So that is one component in your home automation system. That video doorbell exposes a number of things. It exposes events like people pressing the button, and it also exposes a video stream. So the video stream is data that is coming from that device, which could be published to MQTT, and or the information about it. Like, say you might have an RTSP stream, and so information about that could be coming out through MQTT. So then you have another device in your house, which is a door lock. So you've got a lock on your front door, which is controlled by your home automation system. It might have a keypad on it, and or a fingerprint scanner, or an app on your phone to control it, whatever. So you've got a system that has control over the door locks. you can send commands to that door lock to lock and unlock the door. So that's another element in the system. Somewhere else in your home automation system, you might have a computer. It could be like a Synology NAS running some Docker images on it, or it could be a Raspberry Pi or whatever. You've got a computer somewhere in your network, and on that computer you have a little machine learning system which has been trained to recognize faces, and it can distinguish between different people. So it knows your face, it knows your kids' faces, and it knows when other people are not you or your kids. And so what you can do is build a pipeline. You've got these different elements within the system. So part of Andy's vision, and the thing is, he's actually already implemented most of this in different forms. He's got it working in different things. So the vision is that you could build a pipeline where you discover, oh, I've got a video source from the doorbell. I'm going to pipe that video source into my face recognizer. And then the next stage of the pipeline, the output from that face recognizer might be tags that say, I've recognized John's face, or I've recognized Anne's face. That's the output from the recognizer. So now you add another element to the pipeline, and that you take that and you feed that into the door lock. So now what you've got is a system where you can walk up to your front door and your door unlocks, because your system has seen your face through your video doorbell. The pipeline has passed that video stream onto a face recognizer. The face recognizer has said, yes, it's you, you're allowed in. The output of that then goes to the door lock and it unlocks the door. So you can build pipelines of sequences of events. Now that's a very simple pipeline with only 3 elements in it, but there could be many, many more elements than that. And it could split and do more complex logic. But the pipeline itself can be built using the discovered services that are managed by the service registrar, which is what Andy is writing right now. Well, re-implementing. He's already written a service registrar in the past. He's had a version 1 registrar working, and he's now working on version 2. And so that is going to be super exciting, I think. Anyway, Andy does a whole lot of this stuff as part of his day job as well. So I don't want to talk about it too much more right now, because I might be straying into areas that I shouldn't really reveal. Excuse me a second. Yeah, the thing is, this is something that I'm really excited about. And I'm looking over Andy's shoulder as he's writing all of this and developing it. And I'm really impressed. I think it's going to be something that will really get people excited. But I want to defer to Andy in terms of what he reveals and how much and when. And so I won't go into it in too much more detail. But in the future, there will be lots more information. And yes, I would really like to get Andy on the live stream. And Tim, thank you for the bright yellow donation. I really appreciate that. Nice and sunny outside. Yeah. I thought it was going to be wet today. Oh, and John asked, is this an open source project on GitHub? Yep, Andy's already replied to that. And it's currently private, but the idea is that it will all be released as open source. At the moment, it's a work in progress. So it's coming very soon. Yeah. All right. So Thomas Meyer said, yeah, understand the time has to be right. So this is in terms of releasing it. The idea of data versus type and location is already a good outcome for today. Yeah, that in itself is, even without a service registrar and tag-based discovery and all of those sorts of fun things that really will make this awesome, just getting to the point of not caring about MQTT topics is kind of mentally freeing. that's where I've got to myself. So a couple of years ago, so once Andy explained all of this to me, I basically just stopped stressing about the whole thing of how do I structure my MQTT topics, and I just treat it as, well, it's like it's a device with a MAC address. The topic tells me nothing. It doesn't matter. And there will be the full topic, including the suffix, can give you information, but I treat it very much like the way Tasmota does it now, which is, now the topic structure within Tasmota still, I think, is a little bit more complicated than it needs to be, and I get confused about the difference between like stat and teller and all of that sort of thing. So CMND is command is easy, and so there will be structures like CMND slash and then device ID slash power, and then if you publish to that topic, you can turn the power for that particular SON-off on or off. But the device itself, and I know that some people do this, because in Tasmota you can customize the topic structure. You could put in, and I did this in the early days as well, I would name my SON-offs based on their location and give it some kind of a sensible name, so I could look at the name and say, oh yes, I know what that is, but I just don't bother anymore. What I actually do is put %08x in the topic name, and what that does is substitute the MAC address of the device into the topic name so that it ends up being unique. And that way all of my Tasmota devices have the same configuration. It's just prefix slash %08x, and that gives it the hexadecimal format of the MAC address as the topic name, and then I just don't care about it. It's like, it's a device. It is wherever it is, and there are other things that I can use to keep track of what is what. Alright. Frank said, MQTT sounds similar to XPL. I have no idea. XPL, I don't think I've heard of that one. Or maybe I have and it slipped out of the back of my brain somewhere. Yes. Alright. Now, what is the time? 11:53. What? How can it be nearly 2 hours? 2 hours of me just making stuff up as I go. Alright. As I said at the start of this, the only things holding me up right now are caffeine and willpower. And you know that feeling when you're so tired that there is like a buzzing, or like no, not a buzzing, a fizzing in your brain. That's kind of what I feel like at the moment. My brain is just going zzz. So, yep, as Sion said, he's had almost 50 years of making stuff up as he goes. I think that's one of the great realizations, is that everybody is just making stuff up as they go. I always, for so long, I had this thing in my head where I thought, and I think this is fundamental to imposter syndrome as well, there is this feeling that other people know what they're talking about, and everything is planned and organized, and everything is under control for them. And for me, I don't know what's going on, and I'm just trying to figure it out. And eventually you realize that a lot of the time they're just bluffing and they're figuring it out as well. All right, so, Frank McCallendon put in ESP Flasher. Yes. Oh, and Aaron, I forgot to tell you, I sent you a package. So ESP Flasher I'm looking to my left because I've been sitting on my bench right here for ages. ESP Flasher is done. I am going to, in fact, I could even do it today. The only reason that I haven't actually made them live on the site is that I was wanting to accompany it with a bunch of documentation, including a video, which I haven't yet done. But people have been waiting for this for so long that I'm inclined to just release it and try to catch up with the documentation as quickly as I can. And also during the week, this week, my 1.27mm pitch right angle pin headers finally arrived. 75 days, or was it the week before? 75 days after I ordered them, which is the final part that I needed to make the flasher adapter. Let me see. In fact, I've got one right here. All right. These are the two things, and I've been using it this week on a customer project, so I won't tell you about the customer project because it's secret squirrel business. Let's just have a look at this. You're not going to be able to see it very well because it's small and the camera is on fixed focus, but that is the ESP flasher adapter. USB-C on there. It's got a CP2102N USB to serial converter. It's got a 6-pin header on here, and the idea is that you put the header on your project, and you don't need to build USB into it. This just plugs in and it gives you USB, and it handles the auto reset for the ESP8266 or ESP32 on your target board, and does all of that good stuff. It's got a 3.3 volt regulator on it, so it'll power your project up to 600 milliamps, I think it is. Now with the ESP Flash header format, which has been a controversial and very long discussion with many people, I've got 4 versions of it. There is a 1x6 version in 0.1 inch and a 1x6 version in 0.05 inch, and there is a 2x3 version in 0.1 and a 2x3 version in 0.05 inch. So this one is the most common 1x6 format. And then this little Duvalaki board, oh, this one isn't complete, I haven't put all the headers on it, is what I've called the ESP flasher adapter. And the idea is that you plug this into here, and then that converts to the other format. So it gives you 1x6 in 1.27mm pitch, and it gives you the 2 shrouded header formats. So the reason for that is that on some boards it can actually be really convenient to use a shrouded header as your programming connector, because it means that your programmer is not just plugged into a header and then hanging there unsupported. Instead, you have a proper IDC cable which plugs into a shrouded header. It can't go in the wrong way. It means that it's really firmly clipped in place and you've got a flexible connection to it. So I've been using this header format on projects for both myself and my commercial customers for a little while now. The reason I've had this one sitting right here on my bench is that I've been flashing firmware onto a controller for a customer project, and on that particular board I designed on the shrouded header because it's just super convenient in that particular application. Which also kind of answers one of the other questions that came up. So the question was, what was that? I'm not sure. What have I been up to this week? The last couple of weeks I have been crazy busy, flat out, on a couple of customer projects, both of which are commercial proprietary, so they're not open source projects. I can't show them, but yeah, it's been busy. All right, there is an interesting question there. Sleepy105 said, "Hi there, do you have any advice for those of us who are trying to make safe PCBs but can't spare $1,000 plus to access standards? I want to make PCBs that use mains voltage, but I want to make them safe." Oh, there are two aspects to that. The first aspect is a rant, which is the thing about spending $1,000 to access standards. That, I mean, I kind of vaguely, I was going to say I understand it, but I actually don't. Standards should be free. If you are legally required to comply with certain standards to sell or release devices, you should be able to just reference them online. Now, I know people are going to explain to me the whole economic background to it and how standards are developed, and they've got to cover the cost of developing the standards, so therefore they have to charge for them. I know all of that. I know how standards bodies work and how their funding works, but it's still, the system is fundamentally wrong, I think, in this respect, because if you have standards like, I mean, I've had to pay for standards, and what's really annoying is when you have to pay for standards without being able to see them first, so you don't even know if they're relevant necessarily. For example, with the wheelchair hand heater project that I was working on with Chris, I bought the Australian standards. I'm trying to remember which one it was. It was the Australian standards in relation to heaters, like heating appliances. And it's the standard that dictates things like if you buy an electric heater that you plug into a power point and you just sit it there and it blows hot air at you, there is a specific Australian standard for devices that provide heating like that. And there are other Australian standards, like there are standards around the plug that plugs into the wall, and many standards. And if you're making a product, then you really need to buy the standards in order to make sure that your device complies with them. But that can cost so much money. I can't remember how much the heater standards cost. It wasn't a huge amount. I think it was like $180, but you shouldn't have to buy them in the first place. Those things should just be published. Peter said, weight standards bodies work. All right. Yes. I don't want to get into that too much more. Yes. They cost. John Clark said, yes, standards should be free. They cost, but they are paid for by government. Kind of. Yeah, they're kind of paid for by government. But it's slightly more complicated than that, because the standards themselves are typically developed by a standards body, which might be something like Engineers Australia or some organisation, and that organisation needs to cover its costs. So fundamentally, the cost of developing and maintaining the standards has to come from somewhere. And I understand the basis of a user pays system, but it's as a hobbyist in particular, the cost of buying those standards is a real barrier. A few years ago, many years ago now, there was that whole thing about academic papers being downloaded and published, and this, I could go into a whole thing now. There's this whole thing, you might have seen the show The Internet's Own Boy, Aaron Schwartz, who didn't think it was right that you should have to pay to access academic papers. I might be mistelling the story here. That he downloaded a whole bunch of academic papers and then published them, made them publicly available. It's a similar sort of thing. There are so many structures in the way the world works today that are more gatekeeping than value adding. It's about controlling access to things and then making money off the fact that people want to access them rather than adding value and being paid for the fact that you're adding value. Oh, I could go into a big rant here. Uh, John Clark said, I've been involved with a few software standards as a reviewer and was never paid a cent. Yeah. And he also said they rely on huge voluntary contributions. We've got to this 2-hour point and I'm doing this mental calculation. I'm seeing topics pop up here, like Austin mentioned the Smart USB Hub project. That is something that I've been discussing offline. Well, I hate that term. I've been discussing directly. So Ewan, who I know through LinuxConf, I first met Ewan many years ago at LCA. I don't even know how many years ago. It's probably like 15 years ago. Has been chatting to me about a USB hub concept and pointed out to me the capable robot USB hub, which is quite expensive. This comes back to me mentioning a couple of streams ago about the fact that I wanted to design my own USB hub and make it a hackable sort of thing. And so he pointed me to other hackable USB hubs. And we've been talking about this a little bit on Discord over the last week or so. I don't think I want to get into that right now. That is a whole major thing for another day. I think I'm going to have to call it on this live stream. There are a couple of topics here that would be really interesting to go into in detail. And I kind of do want to, I want to keep talking about that whole standards issue and the cost because I never actually answered the question, did I? The question was, what advice do I have for someone who wants to make, make devices, follow the standards, and can't spare $1,000 plus? Jack's Tech had a very good suggestion, which is get in touch with a uni student. They usually have access to them. Some libraries also have access. Honestly, if you aren't happy to get zapped, I'd stay well clear of mains. Yes, I try to avoid mains if I possibly can because I have been zapped. I don't want to be zapped again, ever again. Alright. And Lee asked a question. I don't actually have an answer for you, but I just want you to know that I'm not ignoring your question. The question was, is there a step-by-step process to run Grid Connect switches on Habitat? And I don't have an answer to that, sorry. I haven't used Habitat myself, and I've got some Grid Connect gear here, but I don't have any Grid Connect switches. So I don't have suggestions for that, but maybe jump on the Discord. Alright, so the very last thing I will do before I go is put in a link to the Discord. So if you're wanting to ask questions, there are many people on the Discord that have used Habitat or other systems that I don't have any experience with. So if you've got questions about home automation or different things that we've been talking about today, the Superhouse Discord is a really cool place to go and ask those questions. And people far smarter than me are there to answer them. So I am going to call it a day and thank you for coming along to the live stream. It's been squirrel chasing today, but remember, next week I am going to grab Droid Cam and I'm going to get the radio microphone linked up so I can walk around, and I'm going to do a bit of a lab tour. So next week, come and join me, visit my lab virtually, and then the week after that, we are going to have Tisham talking about Watnik and his open source energy monitoring project, which I'm really looking forward to. That should be very cool. Yeah, he did a good presentation in January, and I think you'll like what he's done. It's pretty cool, and I'm interested to see updates. So yes, as Frank said, stay safe. Thank you very much for coming along, and I will see you all soon. Now I need to use my hand to to end the stream. So where is this thing? I still need to make one of those little button boxes that I can use to control this. End. Okay, here we go. Go and make something awesome.